Hi everyone, my name is Dr. Amy Moss. I'm from the University of New England. Welcome to UNE's pellet mill. So today I want to take you through the pellet mill, why we pellet and how we do it. So I'm a poultry researcher, which means I need to conduct chicken trials, to do experiments, to work out which feed is best for chickens. But of course, in order to do this, I need to make a pellet. So why is pelleting important? Well, the poultry industry feeds all their poultry pelleted diets. So this is because we want poultry to consume their complete pelleted ration in each bite. So if you had a mash, the bigger particles and the smaller particles could separate out. But by pelleting, we ensure that with every single bite that the chicken gets, it's getting the entirety of all of its nutrients. So this is our research feed mill. If we have a look up here, you can see the actual mill apparatus itself. But because it's for research purposes, it's obviously much smaller than an industry mill. So an industry feed mill is actually about 10 times this big. So let's have a look through the mill. What goes into a pellet for poultry? So essentially first we have the feed grains, which in Australia is usually wheat, and they provide a lot of energy to the chicken. So that's usually about 60% of the diet. Then we have our protein meals, which in Australia is often soybean meal, sometimes also a bit of canola meal, and that's usually about 35%. And then of course we have our fats and oils, which is usually 2 or 3%, which is often vegetable oils, or also tallow can be used. And then we have our miners, which is all of our enzymes, amino acids, vitamins, minerals, that sort of thing. They make up the remaining 2 to 3%. So once you've formulated your diet, you have all your ingredients ready to go, the next thing you have to do is make sure that they're a small enough particle size that the mill can pellet, and that the particle sizes are relatively even. So for our feed grains, for example, if we have whole wheat, or even something like whole sorghum, we need to crunch it down into smaller pieces so that it can go through the mill. So one piece of equipment that we can use is a roller mill, which is what you can see behind me. So essentially an auger drops the feed grain into the top, and 2 rolling discs will just crush the grain, and then it comes out into the bottom tub here where we can collect it. And it will be a much smaller and more uniform particle size. When you're mixing feed, a really important thing is the mixed order of ingredients. So the first things that you want to add in is like your grains and protein meals, basically the dry stuff. And then you want to also add in your miners, and you want to mix that around for say 5 minutes to get a good mix. And then you want to add your oils after that, and then mix it for another 10 or 15 minutes. The reason we add our oils second is if we were to add the oils first, all of our miners and the fine powders that we do add to the feed would stick all up the sides of our mixer. So we really want to avoid that, and we want to get a really even distribution of our nutrients through the pellet. At UNE we also have a smaller paddle mixer, which is great if we're mixing up smaller batch sizes. So essentially what makes it a paddle mixer is that it has these big paddles, and that is literally what turns and mixes the feed. Here I have my ribbon mixer. So that is a 700 kilo capacity. It's called a ribbon mixer because the mixing paddles spiral through it like ribbons. So this is quite large for our research capacity, but obviously not nearly as large as you get in industry. Once we've mixed up our diet and it's ready to go into the feed mill, we then need to get it out of the mixer and into the mill. So the way we do that is we have a flow conveyor here. A flow conveyor is slightly different to an auger. An auger has a spiral running up the centre that draws the feed up. A flow conveyor literally has little cups that bring the feed up. The pros of a flow conveyor, and why you might use it instead of an auger, is that it can elevate feed at a much more steep angle, whereas an auger needs to be on more of a flat slope. Once we've got our feed, it's come up through the auger, it's come up into a holding bin, in through this auger, and now it's ready to get pelleted. So this is the whole main operation. This is the conditioning chamber of the pelleter. So essentially this is the area where the hot moist steam is added in, which allows the pellet to properly bind. So it is heat treated and filled with steam as it passes slowly through this chamber. And then it comes out through here to the pellet die, which is here. Once the feed passes down from the conditioner, it then passes into the pellet die. So the pellet die is the thing that actually forms the pellets. It's basically like a really big sieve. It's a piece of metal and it's got lots of small holes. So basically it forces all of the feed through these holes, which then forms the cylinder pellet shape, and then some sharp knives come along and cut the pellets at the desired length. Then, once our pellets have come out of the pellet die, they then drop down into a cooling box. So basically it blows cool air, allows the pellets to reduce in temperature, and then they also harden. And then from there they get augered up and out and then into a